What is an atom? An atom is the smallest unit of an element that keeps its chemical properties. It consists of a small dense nucleus containing positively charged protons and uncharged neutrons, surrounded by negatively charged electrons. So why understanding atomic structure is important? Understanding atomic structure is important because it explains how atoms combine to form matter, governs chemical reactions, and determines the properties of materials. It is essential for advancements in technology, medicine, and energy production, and helps us understand the behavior of substances at the atomic level. Let us see the timeline of atomic structure. Let's start from ancient Greece, around the 5th century BCE. A philosopher named Democritus came up with a fascinating idea. He believed that if you kept cutting something into smaller and smaller pieces, you'd eventually reach a particle so tiny, it couldn't be divided further. He called these particles atoms. But here's the catch, he had no experiments or evidence. It was just a philosophical idea, far ahead of its time. Now, fast forward to the early 19th century, 1803. When science starts getting serious, enter John Dalton, the man who turned Democritus's idea into a proper scientific theory. Dalton said, atoms are real. He proposed that they're indivisible particles that combine in fixed ratios to form everything around us. For example, water is always 2 hydrogen atoms and 1 oxygen atom, no exceptions. This was the start of the modern atomic theory. Later, things start getting exciting. In 1897, J.J. Thomson discovered something shocking: the atom isn't indivisible after all. Using a cathode ray tube, he found electrons, tiny negatively charged particles, inside the atom. To explain this, he came up with the plum pudding model, where electrons are like raisins floating in a positively charged pudding. Then came Ernest Rutherford in 1911, who completely blew up the plum pudding idea. His gold foil experiment showed that atoms are mostly empty space, with a dense, positively charged nucleus at the center. He proposed a new model, the Rutherford model, where electrons orbit the nucleus, like planets around the Sun. Later in 1913, just 2 years later, Niels Bohr took Rutherford's model and added some much-needed rules. Bohr said electrons don't just orbit randomly, they stay in fixed energy levels, like steps on a ladder. This explained why atoms emit light in specific colors. His Bohr model was a game-changer and made atomic theory easier to understand. But atoms still had secrets to reveal. In 1926, Erwin Schrödinger came along with a new perspective. He said electrons aren't like little planets, they behave like waves. Schrödinger introduced the idea of electron clouds, or regions where electrons are most likely to be found. It was no longer about fixed orbits, it was about probabilities. Later in 1927, at the same time, Werner Heisenberg added an element of uncertainty to the mix. He discovered that you can't know exactly where an electron is, and how fast it's moving at the same time. This is the Heisenberg uncertainty principle, and it's one of the cornerstones of quantum physics. Then came James Chadwick in 1932, solving a big puzzle. Atoms seem to have more mass than expected, but why? Chadwick discovered the neutron, a particle with no charge, that sits in the nucleus alongside protons. With this discovery, the atomic model was almost complete. From 1940s to present, now we reach the modern era. Today, we use the quantum mechanical model, the most accurate representation of the atom. It helps us understand the complex behavior of atoms, like their energy levels, and how they interact with each other. Today, it's used in almost every part of modern science and technology. Let's break down the basic components of an atom, protons, neutrons, and electrons, into simple terms. First up, protons. These are tiny particles located in the nucleus, the center of an atom. They carry a positive charge, which we often think of as a +1. Protons are pretty hefty for subatomic particles, weighing about 1 atomic mass unit, that's 1.67 times 10 superscript 2 kilograms. Their key role? Well, the number of protons an atom has determines its identity. For example, hydrogen has just 1 proton, while helium has 2. This number is called the atomic number, and it's what defines the element. Protons also attract negatively charged electrons, helping balance the atom's overall charge. Now, let's talk about neutrons. Neutrons are also found in the nucleus, right alongside protons, but they don't have a charge, they're completely neutral. Despite being neutral, neutrons are slightly heavier than protons, weighing just over 1 atomic mass unit. So, what do they do? Neutrons help stabilize the nucleus. Think of it this way, the protons in the nucleus are all positively charged and naturally repel each other. Neutrons act like glue, offsetting this repulsion and holding the nucleus together. They also define an atom's isotope. The same element can have different numbers of neutrons. For example, carbon-12 and carbon-14 are isotopes of carbon, with the same number of protons but different numbers of neutrons. And finally, we have electrons. Electrons are incredibly light, so light, in fact, that they're about 1/1836 the mass of a proton or neutron. They don't sit in the nucleus, like protons and neutrons. Instead, they zoom around it in specific energy levels or electron shells, forming a sort of cloud around the nucleus. Electrons have a negative charge, -1, which balances out the positive charge of protons. What makes electrons fascinating is that they're the key players in chemical reactions. They're the ones that move around, get transferred, or shared between atoms to form chemical bonds, like covalent or ionic bonds. How they're arranged in those energy levels also determines how reactive an atom is and what kind of chemistry it can do. So, to sum it up, protons define what the element is, neutrons keep the nucleus stable and give rise to isotopes, and electrons dictate how the atom interacts with the world around it. Together, they make up the incredible building blocks of everything in the universe. Enjoyed the video? Like, comment, and share with friends who are curious about the history of atomic science. Don't forget to subscribe to the Element Explorer for more educational content about the fascinating world of chemistry.